We look normal. Welcome back, guys, to another Workflow Wednesday. If you're new to my channel, my name is Fusion Phil. I create content as well as sell and support Autodesk Fusion 360, or as it's known now, just Autodesk Fusion. This week, we're going to go ahead and cover broaching. I am going to give this a couple minutes. I see you guys out there. If you guys want to let me know in chat that you can hear me nice and clear, as always, you can tell, I think I'm going to start a highlight reel of every time I have problems starting stream. Now, if you guys do have any questions at any time, throw them in chat. Let me know. I want to make sure my audio sounds good. Awesome. Dylan, you show up all the time, man. I'm glad. Sounds good. Everything's working good. So let's dive into this right off the start. So I'm going to go ahead and pull up this image. Now, I do have to give you guys a disclaimer here. I did talk about this a little bit. Fusion can't natively do broaching at this moment. And this model was representation, just so you guys can see, what is broaching, how we're approaching broaching. Now, it doesn't matter if you're doing a blind broach or a through broach in this case, or maybe you're going to even go in and broach, maybe a hex head. They're all kind of the same system that we're going to use today. So for this case, I'm going to go ahead and turn off my fancy broaching tool, and we're going to take a look at nothing more than this bushing. So the very first thing I need to do when doing broaching is I need to determine how I'm going to create that cycle. Both ways of creating that cycle, whether it be trace or using a drill procedure, are going to require this precursor step, which is creating a sketch. So what I'm going to do here is I'm going to start with option 1, and now I'm going to do both of these back to back. The idea here is I am going to create a straight line to create my drilling cycle, right? So as you can see here is I could start with a start point and an end point. Now, you don't need both points here. You could start with one point, and then we could use a pattern to create what's going to happen here. So you don't see or hear anything. Oh, no, Travis. Everybody else can see and hear me, hopefully. Travis, do you share your monitors on, man? The rest of you could all still see and hear me. I'm going to continue onwards because this will be live after the fact and you can come back and see it at any time. So we're still good. Awesome. So as you can see is what we're going to have to do, and this is going to be kind of a tedious process the first couple of times, is we need to set our start point for our tool to come in to make that first cut. Now, what I'm going to do is I'm going to dimension from this point to that first point, right? And the reason I'm going to do this is because everything we're going to do inside of Fusion is going to require putting, of course, decimals in the right spot. But we need to determine from the center of our spindle or the center of our tool as we come down into our part. And to see what that means is if I pull my tool back up here, what I'm looking for is the distance from this cutting edge to center line of my tool. Now, for this demonstration, I am just going to pull those dimensions right here. As you can see, it would be roughly, the length of 0.3 plus my radius, 355, to get that dimension. I know this isn't exact, guys, and this is what you're going to get from your tool manufacturer. So going back to that sketch now, in this case, it has reversed us around, so let's get that tool turned off and look at it the front ways. So again, whatever that distance is, I'm going to go ahead and bump mine up to 0.75. As you can see, that is center line of the tool making our first cut. Now, in this case, that first cut could contact on these flats, and if you wanted to, we could actually inspect this line here. I'm getting a distance of 0.113. This is where you could add in your finish pass, and this is why I kind of like doing the line, is knowing now 0.113 is the total distance outwards I'm going to travel. Now, again, I'm going to change this one more time because obviously I'm not fitting a tool that size in there, so let's bump this down. Again, the key element here is I'm creating a point to start my path from. Now, again, you don't need the line as you did, but again, some of you may want a finishing pass or a final pass that you can adjust and make that a much more tighter fit or open it up based on your tolerances. Now, from here, we're going to go ahead and jump over to the manufacturer side of things. So again, the first system that I'm going to use is going to do nothing more than creating a drill procedure, right? So in drilling, one personal thing I would do is I like to select my tool based on roughly whatever that diameter is of what I'm chasing for a keyway. Now, as you can see here, we could actually pick just about any size drill. I'm going to go with a little bigger one. And keep in mind, this is something that a lot of people don't realize is in the world of Fusion, Fusion isn't going to model when you're machining this keyway. Let's go ahead and swap that tool out. We went a little too small here. So again, we're going to go back to that Fusion library. I'm going to step this up to like a 1/4 inch drill, and let's take a look at it. Give me a quick second here. Looks like, Travis, you got your stuff all set up and you're back to operating. So there's my 1/4 inch tool. Again, now based on our geometry, we're going to do a selected point. So again, this is going to seem a little manual. And what I'm really doing is creating, again, that first path down, right? So from here, I can actually set my heights. So again, as we could say, you know, model top, we could do our selected, or as we're used to now is highest of selected model top. And then my bottom height, this is kind of a neat thing. So we could actually say, you know, lowest of selected, or in this case, maybe I want to select a face. And in this case, we don't want the whole part. We just want that lower edge. So let's get that sketch turned off. And I should now be able to grab that surface. And again, based on my tool, we could create a drill bit that has a flat bottom drill to it. That being said, is I'm going to leave mine as is, again, because we're not going to get very good visual representation out of running this. We're basically creating the code out of Fusion to stick in the machine, right? So again, if you wanted to go through, and this isn't a blind broach, we want to actually break through the bottom 0.1. And in this case, that needs to be a negative. Or you could turn on drill tip through bottom, which is a better way. I just forgot to scroll down. And now we could say 0.1 because it's going to add it to the bottom of our hole through, right? Now, something for all of you out there, I see this a lot. This is just a real quick side note pro tip, is if you don't dock your toolbar, notice how my scroll went away. This drives a lot of people mad when your menu is a mile long. So I highly recommend docking your toolpath over here onto the side. You saw that green line? This allows me to scroll within my toolpath. Now, I'm not going to dive too deep on this, but we can customize our post. And I'm going to show you a little bit about customizing that some of you all out there are going to look for something like a chip breaking cycle when broaching. If you wanted to do that, you could set this up, and I'm going to show you a little bit of how, but what we're going to do for this case is we're just going to do a straight down kind of drilling procedure, right? So there's my first path. Now, I know because we created that line, I know I need to move outwards 113. So what I'm going to do is I'm going to create a setup, and we're going to say new pattern. Now, I need a direction for that pattern. I could still have that sketch turned on, or I could actually pick this edge here. Now, with that, it's up to you how you do this, right? So I would actually say extent, and then that extent could be my 113, or maybe 103, because I want to leave 10 for that final pass, and then I can bump up the number of passes that I want. Now, we could do based on spacing. In this case, this is looking pretty good. Again, neither is right or wrong. Again, using that sketch to my advantage, we're going to see it down here at the bottom. Visually, this makes it very easy for me to either use extent or spacing. Because if I want to do spacing of 10th out per pass, as you can see, as I add additional passes, we're walking further and further and further out, right? So the nice thing about that is you're always seeing this in real time to make sure that we're not going to cross. Let me get squared up here, guys. That final point for my final finished pass, right? Now, all I got to do from here is create a second one of those patterns. Actually, not pattern, I apologize. I'm going to copy that toolpath, paste it in the top. And then again, we're going to go ahead and change my geometry to that last point, making that final finished pass. Again, it's not super clean, but really what we want to generate is the X, Y, and Z coordinates of this toolpath, right? So what you guys are noticing here is because I jumped through my setup, we are traveling directly out on my Y-axis and creating that pattern of broaching outwards in the Y direction, or the 12 o'clock position in this part. Now, for some of you, you're not broaching all the time. We don't need to get super crazy with this. So if I was to post something out like this, one, we need a post processor. I'm going to go ahead and not grab that Fanic post because I was playing around with some interesting things earlier. But let's go ahead and just grab any milling or turning post. Now, in the case of all of your guys' post, I'm going to go ahead and put this in a lovely place where I could delete it later, is you're going to modify your post, or your cycle might be different based off what you're trying to do, right? Now, as you're going to see here is we're going to go ahead and post our G code. And like I was saying, is what we're getting is our XYZ data for that cycle to go down, come back up, move further out, right? So here's our 1224, 1324, 1424. We're progressing outwards, and then we're rapiding down. Again, we could change our heights to make this a little cleaner, but as a longhand version of this cycle, you can see I can utilize this data. The only thing I need to hand edit before going to my machine is taking out my spindle speed in this case and plugging in M19. That would lock my spindle on a lot of machines. And now, depending on your machine, it may be a B or a C, and we could set that to 0. Again, locking or causing a compensation in our spindle to align that broach. Now, if we wanted to pattern even further, and I'm not going to show you guys this because you can reach out to me directly, if we did a circular pattern, we could actually output the C axis automatically to broach, say, a star pattern, or if you needed to do a spline type of situation. So again, by removing the spindle speed, we're not turning our spindle on, we're locking our spindle, clocking our spindle, and then we're just running through our cycle. Now, if you wanted to get a little more technical, let's say you're doing broaching a little bit more, right? Let me go ahead and check the time, guys. We're already at the 15-minute mark, and I was hoping to be much further along, but let's go ahead and revamp this. Let's look at the easiest way to edit our post processor. Again, what we don't want to do, and a lot of people I think are like, I want to edit and have one post. Me personally, I would create a post specifically for broaching that allows me to create a sub program and then do an M98 callout, right? So if I edit this post processor, of course, the Fusion plugin is going to be your best friend here. But we're going to go ahead and go down to milling, and I just need some G code. Now, I can go to that S5000 line, and as you're going to see is right here, it's jumped to the startSpindle code. I can add my double slash here and hit save. I've removed my spindle code, and simply enough, we could do nothing more than writeBlock. Again, we need our brackets, and then we're going to say M19 B0.0, right? And again, with a save, what you're going to see is now it's automatically plugged that in. If you didn't know, you could come up here, you could jump to each one of these lines, remove your retracts, right? So I'm just showing you guys with a couple of backslashes, you could clean up the start or create a custom sub-program generator that is going to force M19 and orientation. But let's jump back into Fusion and let's look at a couple of other ways to do this. So what I'm going to do now is we're going to go back into the design area because I'm going to show you a way to use the trace toolpath, right? So now with the trace toolpath, what I'm going to do is I'm actually going to draw my physical cycle here. And how I'm going to draw that cycle is I personally like to go in and I'm going to create a midplane. So I'm going to go between my two flats and create a plane that allows me to now create a sketch on said plane. Now, for those of you out there, it's going to be much easier for me to see all of this by doing a, where is it here? Inspect, and we're going to do a section analysis of this part. Again, I drew this part on center when we first created it. However, also using that construction plane to my advantage, I can grab that construction plane as where I'm going to split my part. So from here, what I'm going to do is I'm going to do a project, and I'm just going to project the bottom edge of that tool, or that lip, right? So now thinking more like a blind kind of broach, I have a bottom height here. Again, I know my distances from center. We have this other sketch. How you determine that, we could create a brand new sketch on this place or this edge. Again, this is distance from center line of your tool to the tip of cutting, but I can now draw how I want my toolpath to interact, right? So for example, if I want a straight line downwards, and then what I'm going to do is I'm going to place that on that point, and then I want to retract back at an angle, and then I could cycle it all the way back up to the top, or I could allow Fusion's retract to bring me up and out. So as you're seeing here is we're going to go ahead and perpendicular this to the bottom face. Again, we now have our two lines. If I wanted to set an actual angle here, we'll drag this outwards. So 75 plus 90 makes 15 degrees, and then back up and out, right? So from that, again, we're going to kind of repeat what we've done except this time I'm going to jump over to manufacture and we're going to look at a 2D trace toolpath. Now with that trace toolpath, we need to go ahead and define our actual profile that we want to use. So I'm going to pick that first edge, pick it a second time, and we're going to bring it out and up, hitting OK. And then I'm going to define a different tool for this because I can't actually use a drill bit doing this. So let's go ahead. We're going to swap that out for none other than a flat end mill. And with that, what you can see is we're generating that cycle to go down, out, and back up, right? So the idea here, again, is now I have set a system to create a repetitive cycle to which, as we did before, I could go through and say new pattern. Again, I could do a linear pattern, as you guys saw, pick my direction, however you want to set up your pattern, right? 112 based on extent and how many times I want to do that pattern, right? Now, I failed to pattern the path, so let's go ahead and drag that path down in there, and let's reevaluate that pattern. Again, what you're seeing is the down motion and the relief and the back up as we start walking outwards. Now, if you're somebody that likes to edit your post processor and set up a toolpath to be able to toggle on broaching, I'm going to show you how to do that. So what we're going to do is we're now going to post out our code. And what that is going to allow me to do is to edit my post processor. So one thing we did do on this post processor, I did hit save, right? So let's go ahead and remove this. And what I'm going to do is I'm going to remove now the startSpindle. We're going to hit save. And of course, you're going to start out either with your post or a post that works very well for you. And I'm going to create a bore cycle. Again, I'm not concerned about the cycle because I'm going to create a checkbox to disable the spindle and spit out whatever my code is, right? So let's go up to the top. So a lot of people have me edit post and they're like, how'd you learn so much about post processor? Well, it's pretty easy. I just find something that I want and I just duplicate it, right? So I'm going to take this first block here for preload tool and I'm going to go ahead and hit enter. And I'm going to go ahead and paste that back in. And I am going to change use preload tools to use broach. Now, from this, we can change, of course, the terminology and things of that nature. You can change the description. And the one thing I would want to do is, one, I don't want this on by default. So we're going to change that to false. And then I would like this to show up at the operation level of my toolpath, right? So with that, I'm going to go ahead and hit save. And what you're going to notice is nothing has changed here. And if you haven't caught some of my other videos, what I do need to do in the world of Fusion is I now need to use a machine definition for creating this cycle, right? So in this case, I'm going to go ahead and create a brand new milling machine. Again, you'll need to do this on your side as well. This is going to be very valuable if you have machine simulation already. We'll go ahead and add some words in here, and I need to associate that post that we're working on. Now, what you're going to see here is we're associating Fanic post processor to our test machine. We're selecting our machine. And now what you're noticing is that custom property we just built is populating here. Now, I could say don't put it on drilling. It would be wise. Or I could say put it on drilling, not on the normal operations. But again, the idea here is for you guys to see how I can now go into my trace toolpath and I'm going to get post properties, which is use broach. Now we're going to take this a little further. Again, we're going to go back to that post processor that's in my Visual Studio Code. Now I want to be able to, at the toolpath level, set my orientation, right? So again, if I scroll down, what I'm looking for is something with an integer or a plugged in number, right? So again, we just steal this little block of code here. We rotate up. I'm going to throw it right after use broach. Again, now this one is going to be broach OR for orientation. Again, you can call it whatever you want. And then from that, I'm going to leave the integer to 10. And of course, we want that at the operation level. So we're going to say operation hitting save. Now, going back into Fusion, if I go back into my toolpath, we should see both of those items show up, right? So now I can activate the broaching cycle here, and then I can also set my orientation as well. So from here, what I need to do is I need to do a little bit more editing because we've now determined that we have a property, and when we activate that property, what we need to do is to stop the spindle speed from coming out. So how I'm going to do that is I'm going to go ahead and pop open a little cheat sheet here because I worked on this way too late last night and my brain is not functioning as best as it can. But what we're going to do is we're going to start by going in and creating that actual variable. So what I'm going to do is right after here, I'm going to hit enter and we're going to say if. And for those of you out there that don't want to be bored to death by this section, I've actually already put this in the description of this video, and you can copy and paste this to some extent. You will need to change a few little things as you're going to see here. So one, I'm using useBroach, and then from that, we're going to go ahead and create another set of brackets. So with that, we now need to tell it what to do. We're going to say writeBlock. And with that writeBlock, we need to, and we're going to do this semi-write. So we're actually going to say mFormat.format. Now you could actually go in and do it the generic way as you saw me do before, but let's go ahead and make this as usable as possible. Comma. Now we're going to add in, whatever your orientation call out is. I'm just going to use B. We're going to say plus in this case, and then we're going to plug in that other get property, right? So what we're doing inside of Fusion is we're going back to those two properties at the top and grabbing that information, right? If use property is checked, write this block. And with that block, get the property for the B orientation. So again, give me a quick second here. We're going to go ahead and type in our other property, which if I remember correctly was broaching, broachor, right? And then we need to close that out because yours truly, of course, like always, somehow fat fingered something in there. Now, from here, we can go ahead and add in our next block, right? So if useBroach isn't checked, we can actually put an else statement. And then again, another set of brackets. And what that next set of brackets is going to do is startSpindle. And then we need to add that bracket that you saw auto-populate right after the end of it. Now, yours truly, of course, has messed this up pretty good. And I'm pretty good at messing things up. So let's go ahead and double verify a few things. And what it looks like is that lovely red right there is we're missing a bracket at the end here. We're going to throw an end block in there. And now we can see up here at the top left corner, everything seems to be functioning properly. So if I hit save, everything worked right. So as you can see, the spindle hasn't changed. Why hasn't the spindle changed? Well, because that is by default currently set to false. So if I was to go back up in my program, easy way to do this is I'm going to grab useBroaching. And we're going to search that. It's in there twice, which means useBroaching here. And then we have broachor. So we really need to make sure that these properties are the correct ones we plugged in down below, right? So if I change this to true now and hit save, what you should see is true is not defined because one, yours truly is good at math. That's why I'm a machinist. I just can't spell. So let's go back and type in the correct word, which is true, not true. And hit save again. So upon hitting save, what we've seen is nothing has actually changed. So what I'm going to do is I'm going to hit save again because I saw this little dilemma before. And now you guys get to see in real time, why is it that this isn't working? So what I'm going to do is I'm going to verify that one useBroach is correct. And we've done that. And then I'm going to highlight broachor and we're going to hit Control F. Looks like we have both of those. And I'm going to go back to my cheat sheet once again, because you guys send me a ton of stuff late at night to be using. And let's see where we went wrong. If any of you guys out there know where I went wrong, feel free to send me a message and tell me where or why this is not working, because it did work. And yours truly also has a fail-safe plan, which is another post processor that I'm more than likely just missing a comma somewhere. So let's double verify. Again, I'm not seeing anything in here, but let's go back to Fusion and post out real quick just to see what's happening. So again, we're going to go back to broaching. It is set to false, of course. Let's go ahead and change that to true. I was having problems with Visual Studio Code the other day where it wasn't working as well. But in the case of this, let's go ahead and edit our toolpath. We're going to go ahead and say useBroach, and then we're going to post out. And with that, we have our Fanic post tied to our machine. Let's check our G code real quick. As you're seeing, as funny as it is, our G code actually did not update. So let's close that out. And we're going to go ahead and close out the debug file as well and repost it one more time. Again, posting out that cycle. It's funny how you practice this stuff and it doesn't work. And as you guys see this, there's no Hollywood magic over here. This is why we do this live, is it is working upon posting, which tells me something is just being funny inside of here when we're actually posting out that information. So as you can see, with that checkbox and with that orientation, I can now force it at the toolpath level, right? So again, what I'm going to do here is we're going to go ahead and plug this back in as false. Let's go back into Fusion. Again, we're going to go in and post-process. And let's see if it spits it out or if it was because that default. So again, we're getting that correctly posted out. If I wanted to verify this a few more times and torture you guys to stay around a little longer, let's give it 25 degrees. And we're still going to allow broaching because we're going to see that 25 populate. In the meantime, I know some of you guys out there may have questions about this. Let's go ahead and check this program. Now you're seeing B25. Last time we're going to check, we want to make sure that, of course, is without it checked, will it still spit out a normal spindle speed, right? So this allows something like your trace toolpath to actually have a double function based on checking that box. So again, everything is working as intended. So what I'm going to do with that is I'm going to go ahead and give you guys the good old-fashioned spiel like always. And of course, none of my hotkeys are working. So let's go ahead and jump over. So as you can see, there's a lot of ways to do broaching inside of Fusion. Using that pattern will always be your best friend for creating those cycles. Again, we could convert drill cycles to give you more variables like pecking and all that. That gets much more complex where you need to reach out like to somebody, yours truly. You could send me an email down below. Don't forget, we're also doing videos all week long. If you guys find this content super valuable and you like it, feel free to give it a like, subscribe. Don't forget to share it with anybody, everybody, coworkers. Maybe your dad has a CNC machine in his garage. I know my stepdad does. But you could also buy me a beer if you guys like. With that, it's not what you know, it's who you know. As always, have a great rest of your day, and hopefully you have a little better luck first time through than you saw me having today.